Okay, once again, good afternoon guys. This is Teacher Cesar of the Serpods channel, and I would like to continue with our lecture on the mole concept. Okay, and you see today what we are going to discuss is all about the computation of the number of mole. Okay, so nung nakaraan diniscuss natin ang molar mass at we have understood that the molar mass of an element is the same with its atomic weight. Okay, the molar mass of a covalent compound is the same with its molecular weight or molecular mass. The same is true with ionic compound. The molar mass of the ionic compounds is the same with its formula mass. Okay, now based from the example today, if we have 1 mole of substance or sodium element, then the atomic weight is 23 grams, and then it contains the Avogadro's number, which expresses also the total number of particles in 1 mole of that substance. Okay, equivalent to 6.02 times 10 to the 23rd atoms. Okay. The same is true with an example for covalent compound. We have carbon dioxide. It has a molecular weight or formula, molecular weight of 6 grams. Then, it also contains 6.02 times 10 to the 23rd molecules. Okay, another example here is for the ionic compound. If you have 1 mole of sodium chloride, which is our common table salt, its formula mass is 58 grams, and it contains also 6.02 times 10 to the 23rd ions. Okay, take note of the units. Take note of the units of the particles. Since sodium is an element, so the simplest particle of an element is atom. Okay, the same is true with a compound. Example of this, a covalent compound, that is carbon dioxide. Its simplest particle is known as molecules. While for the sodium chloride, our common table salt, its simplest particle is composed of ions. Okay. So with this comparison, with this table, we would be able to make up a certain method of computing the number of mole. And using now the formula mole n is equal to the given weight of the substance divided by the molecular mass of that substance. Okay, so we have we can summarize the formula. Okay, we can summarize the formula this way. You have now the number of mole is equal to the given weight, GWT represent the given weight, divided by the molecular weight. Okay, let us try to have an example. We have here is example number 1. Compute the number of mole in 25 grams of potassium. Okay, so for this example, you have to find out the given from the problem given. Okay. So what is given in the problem is that you have the given weight. That is 25 grams. Given weight of potassium K, that is 25 grams. Okay. Now, another given here is the atomic weight or the molar mass of potassium, which is equivalent to the molar mass of potassium is 39 grams per mole. Okay, so what is required here? What is required from this problem is you are asked to find out the number of mole. That's why n is put as question mark. Okay, for each solution, you have to use the formula, and this is now a direct substitution. you consider the formula N is equal to its given weight divided by its molecular weight or atomic weight. In this case, we are referring to its atomic weight, but this is also known as the molar mass. Molar mass. Okay. Now, you can now substitute the given. No? For the given weight, you have 25 grams. 25 grams. And we have to divide that by the molar mass, which is 39 grams per mole. So we have to cancel the unit gram and the unit gram here. Then what remains now is the unit of mole. And that is now equivalent to the number of mole of potassium. That is 25. Okay, 25 divided by 39. 39. And that is, okay, 25 divided by 39. And that is 0.64. 0.64 mole. Okay, that is now the answer. Okay, now let's consider another example here. Let's consider another example, and that is example number 2. Compute the number of mole in 150 grams of sodium hydroxide. Okay, this time we have an ionic substance. This is actually a basic substance, and we have a basic substance, and of course the molar mass is also equivalent to the molar mass is equivalent to the formula weight or formula mass. Okay. Okay. So, okay. Now, first of all, you have to find out the given. Okay. Given we have here is the number of weight, or the given weight rather. The given weight. So you have now the given weight that is equivalent to 150 grams. Okay. What else? You can compute the formula mass of sodium hydroxide. That's why you may write here formula mass or the molar mass of sodium hydroxide, NaOH. And that is equivalent to, of course, you have to compute the formula mass. And you have now sodium, you have oxygen, you have hydrogen. Okay. From there, okay. Okay. From there, you have to find out the number of atoms in the formula. For sodium, you have only one atom. For oxygen, you have one atom. And for hydrogen, you have also one atom. Okay. Now, multiply them with their respective atomic weights. For sodium, you have 23 grams per mole. 23 grams per mole. And for oxygen, you have 16 grams per mole. And for hydrogen, you have 1 gram per mole. So, compute the products of each of these elements. You have now 23 grams per mole for sodium, and for oxygen you have 16 grams per mole, and for hydrogen you have 1 gram per mole. And if you're going to get the sum of this, you will arrive into 40 grams per mole. 40 grams per mole. Okay. Now, so we have already found, or we have already computed for the molecular or molar mass of sodium hydroxide. The next thing that we are going to do is to find out what is required. What is required? Okay. What is required in the formula is the number of mole of NaOH. Number of mole of NaOH. Okay. So, with this, we have to put this as question mark. And then, let us now move on to the solution of the problem. Solution of the problem. You have also to use the formula N is equal to the given weight divided by the molar mass of the substance, which is also the same with the formula mass of the sodium hydroxide. Okay, so this is now by direct substitution. You have the given weight, which is equivalent to 150 grams. 150 grams divided by its formula mass or the molar mass, that is equivalent to 40 grams. 40 grams per mole. So you have to cancel the unit grams, and then what remains now is expressed in mole. Okay, so therefore the number of mole of NaOH or sodium hydroxide is now equivalent to 150 divided by 40, and that is now 3.75 moles. Okay, so that is now the number of moles for sodium hydroxide, which is given as a sample of 150 grams. Okay, so another example here. Let us consider another example. This is now example number 3. Okay, let's consider example number 3. Okay. Let us now erase this part. Okay. And then let's make an adjustment of our camera. Alright. Let us adjust our camera. Okay, to be able to see the problem here. Okay. Is it clear now? Okay. That's it. Okay. So we have another problem here. That is now number 3. Problem number 3. And it says here, what is the mass of 2.75 moles of sodium carbonate? So this time, what is being asked is the given weight. The number of mole is given. Okay. And it is also possible that we can compute for the formula mass of the substance. Take note, this is ionic substance, sodium carbonate. When it is dissolved in water, it will give us an aqueous solution. Okay, so now with this first, we have to find out the given in the problem. Okay, first we have the number of mole. The number of mole is equivalent to 2.75 moles. Okay, 2.75 moles. Is it clear? Okay, now let's make it closer. Alright. Okay, next we have also the formula mass of sodium hydroxide, or the molar mass of the sodium hydroxide, which is sodium carbonate rather, Na2CO3. Alright. So, as usual, we have to write the elemental composition of this compound. So, we have sodium. Next, we have also carbon. And then we have also oxygen. Now, let's find out the number of atoms present in the molecule. For sodium, we have 2. And for carbon, we have 1 atom. And for oxygen, there are 3 atoms. Then, let us multiply them with their respective atomic weights. For sodium, we have 23 grams per mole. And for carbon, we have 12 grams per mole. And for oxygen, you have 16 grams per mole. Then, let's try to find out the products of this. So, we have, this is 46. We have 46 grams per mole. And then you have also 12 grams per mole for carbon. And you have, this is, okay, sweet, you have, alright, you have 48. So we have 48 grams per mole for oxygen. And then let's add. You have 46, 12, and 48. Then it will give you 106. So 106 grams per mole. And this is now the formula mass of sodium carbonate, or this is the molar mass of sodium carbonate. From here, let's try to find out what is required here. Alright. Now, based from the problem, what is being asked here is the mass of the substance. The mass of sodium carbonate. So, that means to say you are going to look for the GWT, or the given weight of the substance. Given weight of sodium carbonate. Alright. Now, the solution is like this. Simply, we have to derive the formula from the formula N is equal to the given weight divided by the molar mass of the substance. Since what we need here is the given weight, then simply conduct a crisscross multiplication, so that you will have now a given weight is equal to the number of mole multiplied by the molar mass of the substance. Okay, so that's it. And we can now substitute the given. Alright, what are the given? You have the number of mole of the substance, that is 2.75 mole. And then that will be multiplied by the molar mass, which is equivalent to 106 grams per mole. So that is 106 grams per mole. So the number of mole, the unit mole, and the unit of moles are cancelled. What remains as the unit is expressed in gram. So that the weight of sodium carbonate now is equivalent to 2.75 times 106 grams, and it gives you now 291.5 grams of sodium carbonate. So this is now the answer. Okay, that is now the answer of that problem. Alright, next, another problem here. I'm going to present to you is that suppose that you are asked to find out the number of molecules or the number of particles in a given weight of the substance. So this is a little bit tougher, because you need to find out the number of particles of a substance. Alright, so let's try to make it a little closer to make the video clearer. Okay, now that's it. Alright, okay, so this is now example number 4. Example number 4. Okay, the problem goes like this. Are there how many molecules of sucrose C12H22O11 in 15 grams sample? In 15 grams of sucrose. Sucrose is our common table sugar. Okay. Now, what we are going to do this time is to find out the given. Alright. From the problem, we have here the given. Okay, the given here is that you are given 15 grams sample of sucrose. That is the given weight. Alright, that is 15 grams. Okay, what's next? We can find out or we can compute the molar mass of sucrose, since its formula is C12H22O11. Okay. Now from there, we can find out their atomic weights, or the total weight of these elements in the molecule. You have now carbon. There are 12 atoms. And then we have hydrogen. There are 22 atoms. We have oxygen. There are 11 atoms. Okay. With that, we have to multiply them by their respective atomic weights. So for carbon, you have 12 grams per mole. While hydrogen, you have 1 gram per mole. And for oxygen, you have 16 grams per mole. Okay. So guys, the next thing that you're going to do is find out the products of these elements. No? Okay. So we have here 12 and 12. Okay. We have to use our scientific calculators. Take note, we need to use scientific calculators because later on, we will be using exponential values. Okay. So, we have now 12 and 12 atoms. You have 144 grams per mole. And then for hydrogen, you have 22 grams per mole. Okay. And then for oxygen, you have 176 grams per mole. And you're going to add this, it will give you 342 grams per mole. Okay. Now we have computed the molar mass of sucrose. The molar mass of sucrose. Now that is included in the given since it reflects on the problem. So what is required here? What is required here? Okay, required here is the number of molecules of sucrose. Number of molecules. Question mark. Okay, that's it. Now, since the particle is being asked, now we can use another formula here. So, to find out the number of molecule of sucrose, you have to multiply the number of mole by the Avogadro's number. Avogadro's number. Okay. So that Avogadro's number is equivalent to 6.02 times 10 to the 23rd. Okay. Now, the first thing that we have to find out is the number of mole. Because the number of mole is not presented in the problem, but rather we have to compute this first. So the number of mole is equivalent to its given weight divided by the molar mass. The molar mass of sucrose. Okay. Now, with that, we have to find out the given weight, that is 15 grams. 15 grams divided by the molar mass of sucrose, which is 342 grams per mole. Okay, we have to cancel the unit grams so that the remaining unit now is expressed in the number of mole. Alright, and this is now equivalent to, okay, 15 divided by 342. Okay, so you have now 0.044. Okay, 0.044 moles. Okay, this is now the number of mole of that sugar, which is equivalent to 15 grams. But what we are looking for is the number of molecules. So from here, you can now substitute the number of mole in the first formula, and then of course substitute this Avogadro's number by its figure. Okay, so that the number of molecules of sugar in 15 gram sample is now equivalent to the number of mole, which is 0.044 mole, multiply that by the Avogadro's number. Multiply that by the Avogadro's number, which is equivalent to 6.02 times 10 to the 23rd. Since the particle of this, since this is a equivalent compound, the particle of this is molecule. Molecules per mole. Okay. So that is how the values. Alright. Now what we are going to do here is you have to cancel the unit mole or moles, so that what remains now as the unit is expressed in molecules. So simply, what we are going to do with that now, you have to compute in your scientific calculator. Take note, you cannot use an ordinary calculator here because it will not accommodate the value 6.02 times 10 to the 23rd. So that would now be equivalent to 6.02 exponent 23 times 0.044. Okay, and you have now the value 2.65 times 10 to the 22nd molecules. Okay, so that is now the number of molecules of C12H22O11 with a given weight of 15 grams. Okay, so that is how to compute for the number of molecules. First of all, you have to be familiar with the formula. The number of molecule is equivalent to the number of mole times the Avogadro's number, where the Avogadro's number is equivalent to 6.02 times 10 to the 23rd molecules or particles per mole. Okay, so guys, that is now the way, or the proper way of computing the number of moles, the number of or the given weight of the substance, as well as the number of molecules in a given weight of a certain substance or a particular substance. Okay, guys, we stop here, and once again, I hope that this help you in your studies, especially with regards to the molar concept. Now, if you like this video, and if you want to receive more videos, just subscribe and anticipate for the coming another videos where you can be of help. You can be used in your studies. Thank you very much, and good afternoon.